Hi everyone. In this video session we are going to write a program to represent a binary tree as a string on console. So why do we need to represent a binary tree as a string? As you might be knowing that console or command line interface is not a graphical user interface, right? So there we cannot graphically represent or print a binary tree. We need to print some string on it. So if we are able to represent a binary tree as a string, then it can be used in several video sessions where we implement binary tree algorithms in C to tally whether the algorithms that we have implemented are working correctly or not. So that's the purpose of this video session, and once for all we want to represent a binary tree as a string on console, and then can use the same representation in the other videos where we deal with implementation of binary tree algorithms. So let's get started with our first example and see how a binary tree can be represented as a string. So on the left hand side you are able to see a binary tree, and on the right hand side we have a string representation of this binary tree. So one thing, please notice that this is not the only representation that can be that we can have for a binary tree. That's a convention that we are using for our upcoming videos, which deals with binary tree algorithms implementations in C, right? So that's not the only representation. That's our convention of representing a binary tree as a string, and this would be used in all the videos in all the videos that I make on binary tree algorithms implementation, right? So let's see how this tree has been converted into a string. So first of all, the label of root is printed out, and after that an opening square bracket is printed out, and after that we are representing the left subtree of f, that is root, as a string. So this whole string represents the left subtree of root, and then followed with a comma, and then a string representation of right subtree of the root. So this is the string representation of right subtree of the root, and at the end we are closing the square bracket. So this is start of the square bracket, and this is end of the square bracket, and within the square brackets we are representing left subtree and right subtree of the root. Now coming to the left subtree, the string representation of this left subtree, so this is the left subtree, and the string representation of this left subtree is given over here, which again recursively we can see that b is printed out first, and then we have a opening square bracket followed with string representation of b's left subtree, that is just a, comma, string representation of b's right subtree, that is DCE. So this is the string representation of this right subtree of the node B. Now coming to right subtree of f, if you see, right subtree of f consists of these three nodes G, I and H, and the string representation of this particular right subtree of right subtree of f is given over here. So we are printing out G first, and then within this square brackets we are printing the left subtree and right subtree of G. As you might be seeing that left subtree of G is null, and in our representation we have chosen to represent a null subtree by underscore. So here it is null, so after the square bracket we are printing out underscore to represent that the left subtree of G is null, followed with a comma, then string representation of right subtree of G. So this is string representation of right subtree of G. Now again recursively, if you see, this subtree is represented by printing out I first and then square bracket, then I's left subtree is having H, so we have printed out H followed with a comma, and I's right subtree is null, so we have printed out underscore, and then we have closed the square bracket which has started here. So this is how we are printing the binary tree as string. And one thing you might be noticing that we are not representing the string representation of left subtree and right subtree of a node where both the subtrees are null. So if both the subtrees are null, like that we have for C, for A, for E, where and H, where both the subtrees are null, we could have represented, let's say A, after A we could have represented its left subtree and right subtree by this string. So we could have used this string to represent left subtree and right subtree of a node which is having both the subtrees as null, right? Square bracket. So we could have first printed out the label of the node that we have already printed out, like A, and after that we could have represented or printed out its left subtree and right subtree by this string. But we have skipped this because we do not want to clutter the string representation with these strings. We would skip it. So now let's take another example. So here you can see another example, and its string representation is given over here. So you can just pause the video and tally whether you can convert this binary tree into a string, and then compare it with your answer and see if it is correct or not. So now let's head to the code editor and write a program to represent a binary tree, an in-memory binary tree, as a string on the console. So we are here at the code editor, and now we would be writing a program to represent or print a binary tree, an in-memory binary tree, as a string on the console. So first of all, to hold a binary tree in memory, we would have to hold its node. So for that we need to declare a data type. So we would start with declaring a data type. That would be a structure data type, and let's call the structure as node. And each node of the tree contains three things. One is the data, and other two things are the pointers to left subtree and right subtree. So let's declare that. Let's say the data is integer data, and the pointer to left subtree and right subtree would be of type struct node asterisk. So these two pointers are used to keep the addresses of the left subtree and right subtree. Now as we would be using this data type, that is struct node asterisk, many times in the program, so let's use typedef to rename it and have a shorter version of the data type. So you might be knowing that typedef is used to rename a data type. So here struct node asterisk, this is a single data type. So let's give it a better name, and by convention it should be in capital. So node ptr now represents wherever we would use struct node asterisk. Instead of that, we can now use node ptr. So now let us use this new representation, this new name of this data type here. Alright, so we are now having this data type which can hold the data of a node. Right, now let's write a method to create a node in memory dynamically. So let's name it as create node, and this method is going to take as parameter the data to be stored in this new node. And it is going to return the pointer to the new node which got created dynamically in memory, and so the return data type is node ptr. So let's use malloc function, which takes as parameter the size of the of the data that it is supposed to take create in bytes. So we would be using size of operator here and pass to it the struct node data type. So size of operator would calculate the number of bytes those are required to hold a data of this type, and it would pass it on to malloc, and malloc is going to allocate those many number of bytes in memory, and it is going to return void pointer. So we need to convert it into node pointer and store it in a variable. So let's call this new node here with this variable, and as we are getting as parameter the data to be stored in new node, so let's initialize the data field of this new node that got created in memory, and we would set the left pointer to null and right pointer to null. Now it is going to return this new node to the calling function. So now we would be using this method to create the binary tree in memory. So the binary tree that we would be dealing with is this one. So this is a binary tree that we are going to create in memory, and after that we are going to write a function which would convert this binary tree into this representation, right? So let's create the binary tree first. So the first node, as you might be seeing, is 2, right? So let's create this node in memory. And let's name this variable as root, and we would be using create node function, and to that we would be passing value 2. So this function is going to create the root of the tree, and it's going to return a pointer to it, which we are storing in this variable root. Now let's call this 7 as node 1, and use again the create method to create it in memory. So likewise we can create all the nodes of the tree, right? So let me pause this video for a moment and type everything by which we would be creating all the nodes in memory. Now I've created all the nodes in memory. Now it's time to set up the links between these nodes. So on the left of root we have 7, on the right of root we have 5, and these are represented by the variables node 1 and node 2, right? So node 1 is 7 and node 2 is 5. So the way the links would be set up is like this. So on root's left we are going to store the address of node 7 that is stored in node 1 variable, and on the right hand side we have this node which is represented by node 2. So likewise we would set up all the links of this tree. So let me pause again and then type all the links. So I have created all the links between the nodes. So first we created the nodes in memory, and then we set up all the left and right links. So see one thing, notice here one thing, that we are not setting up the left subtree link of 5. Here if you see 5 is stored in node 2, and in node 2 we are just setting up the right subtree. And because the left subtree of node 2 is null, right? Because it is null, we are not storing it. This is because we have already initialized the left and right subtree of a node by null. So there is no need of again setting up the left subtree of node 5 with null. It's already done when we are creating this node. So now let's write, so after this tree is created in memory, now this is time to convert the binary tree into a string, right? So for that we would be writing a new method which should take as an input the root pointer of the tree and then print out the string representation of it on console. So this function is going to return nothing, and as an input it's going to take a pointer to the root of the tree that it is supposed to print on console. And when we were discussing, I said that we are recursively printing the representation of the tree on the console. So here 2 is printed out, and then we are having square bracket, and then this left subtree is recursively printed out here, and the right subtree of 2 is recursively printed out here, right? So by definition it's recursive, so we would be writing a recursive function for printing out this binary tree on the console. And on a recursive function, the first thing that we start with is the base case. So here base case is if a tree is null, then we are going to print underscore. That is our chosen representation of a null tree. So if root is null, we are going to print underscore and just return. And if it is not null, then we are going to print, first of all we are going to print the label of the or the data of the node, data of node is accessed by this root arrow data. After that we are going to print opening square bracket and then we are going to recursively print the left subtree of the root. So for that we would be recursively we would make a recursive call to print node. It's better to name this as print tree, that would make more sense. So let me rename it to print tree, and we are going to print recursively the left subtree of root. So for that we would be passing in to this recursive method call the pointer to left subtree, and after left subtree is printed out, we would be printing out a comma, and then we'd recursively print out the right subtree, followed with a closing bracket. I think that's it. This is going to print out the tree on the console. One thing that we have missed is a check with when the left and right subtree both are null. At that case, we don't want to print opening bracket underscore comma and closing bracket. So that thing we need to skip, and for that, after printing the data of the root, right, we would check whether the root's left subtree and right subtree are null or not. If that's the case, then we are going to just return. So if left subtree is null and also right subtree is null, no need to print anything, just return. Sorry. Now let's call this from main method. So I'm calling this from main method and I'm passing in the pointer to the root of the tree, and let's see if it works correctly or not. So if you tally these two answers, I think it's correct. So we are done with this implementation, and it has worked correctly. So thanks for watching. Bye.